Okay, sorry for the delay. We'll finally get started. So today we'll talk about SQL, and and here we're just going to cover like interacting with SQL and running queries on SQL. And so I know as you go out and search for jobs, a lot of job listings say you're going to need to know SQL and stuff, and this is mostly because somebody has already set up a database and you will need to be able to interact and run queries to get the information out of the database. Okay, um, it's quite complicated to set up and create your own database and create your own SQL server and all that. And so that is not part of this class, and I'm not going to be covering that, okay? Because you are probably not applying for a database administrator job, okay? That's the person who's going to be in charge of setting up the database and maintaining them and running the servers there. That's not how we generally interact with databases. Generally, a database is set up and you connect to the database, you run a query, you get information back from the database, and that's what you do, okay? A lot of SQL is similar to, say, dplyr, okay? And so we've covered dplyr in like 102A and other courses and stuff like that. And so the way you interact with SQL is quite similar. I've listed off a couple resources here, okay? One here is just this thing of SQL exercises. So, if you're planning on applying for a job and it talks about you need to know SQL and stuff, there's a bunch of exercises here, okay? And so it'll say something like, it just starts off with kind of easy, simple things like retrieving data from a table, and it says, here's your table, and what is the what's the SQL statement that you need to run to basically display all the information from all of Salesman, okay? And so the table name is Salesman. So we'll cover this, but the answer is going to be like select star, like select everything from Salesman, right? And then you can click here to click the solution, and it will tell you that the answer is select star from Salesman, okay? And it's quite it's pretty easy, but I think this is a very good resource. A nice thing about this is that it has this online editor where you can type in your queries and run it, and you can see the result of running your table, okay, running your query. So that takes care of kind of the biggest hurdle of like practicing SQL on your own is like trying to find an appropriate database to practice on. There's like a buzzing noise, but okay. So anyway, so I think that's a great W3 resource, SQL exercises. Another place, if you want to kind of play around with it, is called SQL Fiddle. This here requires you to build a schema, okay, which can kind of be a pain. And so for something like this, you will have to kind of look up some kind of database schema. You can kind of look at, so here's like the sample thing, and they've kind of created the schema here, and then you can kind of run your queries over here. So that's another useful thing, okay? For us, we're going to use this pre-made database called Chinook SQLite, okay? And I don't actually want to open it directly. All right, and I think I've uploaded this, and this is an open source data set that I've kind of got from, I think, the SQL tutorial, and it kind of shows off the structure of this thing. Okay, so this is I'm sorry. Here's the thing. Okay, it's the name Chinook comes from. It's based off of back in the day when Microsoft was one of the not original, but they had a SQL server. Microsoft SQL, Microsoft SQL, and they had a sample database called the North Winds database, and this is based off of that. And I guess Chinook means north wind in some language I don't remember, but that's where we go. And so so this first part, we're gonna just import pandas, and let me clear everything. Restart the kernel. So we're gonna just okay. So we're gonna start here, and we will create a connection to the SQL database. Okay, so the SQL database is stored for us in this file, the SQLite file. And there's all sorts of SQL variants. There's like Postgres, and there's like MySQL, and I don't know, Oracle, and Microsoft, and they're all like at the base, they're pretty similar, and they just have like a few things that are ever so slightly different from each other. But SQLite or SQLite is kind of the it runs just simply on your machine. You don't have to set up a separate server. You just kind of need the file, and you can create a connection there. Okay, so that's what we have. I guess before I go on, so SQL. We call it SQL, but that's technically not what you're supposed to call it. I think everybody calls it SQL, but it's technically SQL, and it stands for Structured Query Language. Okay, and the idea is everything is stored in tables, and the tables are kind of linked together. So you've got different tables, and they're all linked together. I don't think that was me. They're all linked together, and one thing that's kind of an issue is you're not allowed to have missing values. Okay, and in SQL database, there's no missing values. So if you have a missing value, you have to put something in there. So you have to either put in a dash if it's like characters, or if it's numbers, you got to put in like -1 or 9999 or something. You're not allowed to. I don't know. Are you allowed to put in nans into SQL? I'm not entirely sure, but basically, if you're in a situation where you're expecting lots of missing values or things like that, an SQL database might not be the correct solution. But usually, you don't get a choice over this. Usually, the data is already created for you, and it's being amassed in some database, and we just need to connect to it. Okay, so I'm going to use. There's a package called SQL Alchemy, and then we can just use Create Engine, and this is going to create a connection that allows us to interact with SQL using pandas. Okay, so this is it. Just import Create Engine, and then we're going to run Create Engine on the file, and this, we call this engine, and we can kind of start doing this, and we can just kind of check to make sure that our connection is indeed working. And so we can just ask for the table names, and indeed it looks like it's good. Okay, so we get the tables. The tables that exist are album, artist, customer, employee, genre, invoice, invoice line, media type, playlist, playlist track, and track. Okay, so it's some kind of the database here is basically imagine you're some kind of like music store, and you get customers who want to order like music and albums, and so you're keeping track of the orders and the customers, And then on the other side, you also have to keep track of the music itself, okay? And so those are stored in albums and tracks and that kind of information. Okay, and so the way we interact with SQL here is we create a connection, okay? So we open a connection, so we do engine.connect. We create a very simple query. The query, like the easiest, is going to be select star from album, okay? So this is going to be basically select all the columns from table name, okay? So there's a table called album, and this is basically just going to be select everything from the table album, okay? The SQL is not case sensitive, okay? But there's kind of for the style format is that all of the SQL keywords you generally write in all caps, and then the things that are pertain to the tables and the variables and stuff, you generally use the kind of the case that matches the tables. But this should work whether I capitalize or don't capitalize things. Okay, so this is the query that I'm going to run, and then and so these get kind of our search, our RS, the query. And then we're going to ask, the way we save the results of the query to a data frame is we're going to run the fetch all command from RS, okay? And you don't always have to do fetch all, you can just like fetch the top 10 or whatever. And then we're going to throw that into a data frame. We close the connection, and then we can look at kind of the head of the data frame. We can look at kind of the results, the keys of our query results, okay? And so when we do this, when I do select all, the head of my data frame looks like this, and it comes back saying, 1, 2, 3, 4, 5. These are the album IDs. The title is this, and the artist ID is this, okay? So so our first, in row 0, this is album ID 1, and the title of the album is For Those About to Rock, We Salute You, and it comes from artist ID number 1, okay? Artist ID number 2 is here, and that artist wrote Balls to the Wall and Restless and Wild. Anybody know who these artists are? Let There Be Rock? All right. Is anybody familiar with these, right? So so that's what we have, right? So we can say, For Those About to Rock, We Salute You. So that's a album by AC/DC, okay? And then we can also just check Let There Be Rock, and that should also be is another album from AC/DC. Okay, so artist ID 1 is going to be AC/DC, and they've written these two things. All right, and so so one thing about kind of the SQL database strategy is to minimize duplicate info. So you don't want to have, so in column, for the artist ID, they didn't actually write AC/DC and AC/DC and things like that. They just wrote artist ID 1. And so there's going to be a separate table that lists off the artist names and the artist IDs, okay? And that way, you don't accidentally write AC/DC in all caps in one place and with lowercase letters in somewhere else, and get mismatched information. All right. Kind of maybe a slightly more efficient way to do this is that, because if you do it this way, you open the connection and you're supposed to close the connection. What you can do is you can write kind of this little set here which says with, and then you're going to basically open the connection here, engine.connect as con, as the connection, and then when it's done executing these commands, it's going to close it automatically, okay? And so here we write up our command or our SQL, and here is just going to be select last name and title. So we're going to select these two columns from the table employee, okay? And so you can do multiple lines of a command using triple quotes. So I've got command, and then again we're going to just select the last name and the title from the table employee, and then we will just execute it within here. We execute the command, and that gets stored as results, and then we fetch the results and we put that into the data frame, and we'll also ask for the keys of the results and name our data frame columns accordingly. Okay, and then so when I do that, I get last name and title, and we get Adams as general manager, Edwards as sales manager, Peacock and Park and Johnson. These are all sales support agents and things like that. Okay, so this is what we have in our employee table. Okay, looks like we have 8 employees. Okay, even quicker, Pandas just has this thing that just says read SQL query, and you can just give it the command and give it the engine, and it automatically does all of this stuff for us. Okay, so I think this is what we're going to just use from here on out, just to kind of showing like this is kind of our traditional way to get Python to or Pandas to interact with SQL using SQL Alchemy. But here again, we've created the engine. This is our engine, is kind of the connection to the database here, and then we're going to just run that connection, and then run the command, which is still this thing, and we can execute that, and we get exactly the same results as before. Okay, so this is kind of just what we'll use, and then so now I'll talk about the SQL commands. All right, so far so good. Okay, so we've already seen select and from, right? So select is basically you name the columns that you want to select, and then from is which table you're going to select from, and then you can do things like ordering it, and you can do order by, and you give it kind of the column that you want to sort by. Okay, so order by will be to sort the thing, and so we can just run this, and so basically it's going to be select all the columns from the employee table, and rather than appearing in the order that they appear in the database, they're going to be sorted by birth date and descending. Okay, you can do ascending or descending, and here we'll do it descending. Okay, and so these are all the columns in our employees table, and there's only there's 8 employees, but we got a bunch of columns. We have their employee ID, last name, first name, title, and then birth date, and descending. Okay, so our youngest employee is Jane Peacock, born 1973, and our oldest employee is Margaret Park, born 1947. Okay. So this is, and that's what we've got there. Okay. And this is all of the other information. I guess everybody's in Canada. Okay, so that's what we have there. So if you want to filter the row selection, okay, you can use the command where. Okay, so you can do something like where employee ID is greater than or equal to 6 and title is equal to IT staff. Okay, now here's one thing that requires some getting used to in SQL or SQL. They use a single equal sign for comparison. We're always kind of accustomed to equal, but in SQL it's just a single equal thing. Okay, so basically if we look at this, we're only going to select, who are we going to select? If this is the database, we want where employee ID is greater than or equal to 6. Actually, we don't have employee ID here. We only have index. So it's technically 1 through 8. So we're going to look at 6, 7, and 8, and we're going to pick where it's IT staff. So we're going to pick King and Callahan because their employee IDs are 7 and 8. And they have their title is IT staff. We're going to sort them by birth date, and so we get Robert King, Laura Callahan, and it's sorted by birth date 1968 then 1970, okay? If I wanted in descending order, I could do order by birth date descending or something like that, okay? So, so this is kind of like dplyr where filter, but you use where, okay? Depending on how big the table is, you might only want, so generally, your database is running on a separate computer and your computer connects to it, okay? Here we've got the file, the Chinook SQLite file running on our local computer, so it's not like, there's no like bandwidth considerations, but it's also possible that like you're working for some global company and the SQL server is like in Germany or something like that. And if you want information, you've got to like run a query, it sends it over to Germany, they run the commands and then they send the information back, okay? And so in that case, you might just want to see if your query even works in the first place. Like you might expect like thousands of rows or like millions of rows, but that's gonna take a lot of time to send back, okay? And so, so you might want to limit how many rows for it to search and return. You don't want to like force break your connection if it takes too long to run the thing, okay? Usually it takes like a couple times where you didn't include the limit thing and you're like waiting 5 minutes to get all of your results and you realize, okay, I'll use limit here, okay? And so limit 10 just, does exactly what you want. It's kind of like head, all right? It just gives you the first 10 things back and this is what we get, okay? Anybody recognize any of these albums? Okay, never mind. Jagged Little Pill, Alanis Morissette. All right. This is, the database was like, I think made in early 2000s, right? So this like our higher date is like 2004. It's like 15 years ago now. Okay. All right. And this is kind of really, you have to master the joins, okay? So the join statements are really what powers SQL. I mean, you might be able to get all of your information from a single table using just filter, where and select and order by or something like that. But generally the information you want is going to be across multiple tables. And so you have to join the tables. So here, we might want to know not just the title of the album, but also who wrote the album, okay? And so we're going to have to join the album and artist table, okay? And so here I'm going to say I want everything, okay, from the album table, and we're going to join it, and I'm going to run an inner join on with the artist table, okay? And then the way we do joins is we specify which column in one table should match or like basically look up values in the other table, okay? So let me, well, I guess before I do that, let me just kind of show you what. So I'm going to say select everything from artist, okay? And this is what our artist table looks like, okay? And so we can see we've got, this is the artist ID, and we're going to just basically look up this number over here, and every time we see the number 1, we're going to return, we want ACDC, and every time we see the number 2, we want accept, okay? And so here we're going to do from album joined with artist, and we're going to say the artist ID column and this artist ID column is where they are joined. So you say on album.artistid is equal to artist.artistid, okay? And that allows for like, you might call it artist ID in one table and it might be called like, I don't know, band ID or something, right? There might be a different thing, and so the notation is table name dot column name, okay? So in R you use $signs, but I think, in pandas they use dot, so notation, so this is not too strange. In SQL, they also use dot notation. Okay, and so this this selects everything, and we join up artist ID, and we get you know, all of these things. Okay. And so, you know, maybe you don't want maybe we want to know how many artists and stuff. So this is kind of like the full table. I guess if you don't want to have like this duplicate artist ID stuff in here, you can, instead of doing select, we can do select title, and then we would probably have to specify album.artist ID and name, and we'll get something like this, or we can probably even just hide something like this. Okay. Let me see. I think I can do as album title, name as artist name. Okay, so you can also rename your column headings using as. Okay, if you want, things like that. Okay, so this is same thing, but now we've didn't select everything. Okay. Let's see what else I've got here. Oh, I guess I'm gonna run out of time here. Well, I mean, we'll process through all of this very quickly. Okay. Okay. So we've got the inner joins, all right, and then now we have we can look at doing group bys. Okay. So here we've joined the artist table with the album. I'm sorry, yeah, album table with the artist table, and that's what we have. Okay, this time we're going to select the artist ID, the name, and what we want to do is we want to count how many albums we have. Okay, but we are going to kind of, so when we do the group by, let me just show you what happens here. If I remove this group by, the count just gets aggregated for the entire table. Okay, which is, why is this not working? Okay, because I did count album ID. So this is kind of an aggregate thing. But here I can do group by, and then now we'll get one row for every artist ID. Okay, and so this tells me that as far as our table goes, okay, our database goes, AC/DC had 2 albums, and Accept has 2 albums, and these all have one album each, and things like that. Okay, so we now have kind of like this summary information, right? And there's other things. You don't have to just do count, but you have like SQL aggregate functions, and you have a bunch of these things: average, count, min, max, and sum, things like that. Things that I think we're accustomed to seeing. And so so these are kind of some of your basic things that you can do. Select everything. I guess this. Select everything from album order by artist ID. This is not going to be. This is just kind of verifying exactly what we see up here, in that AC/DC had 2 and Accept has 2, and AudioSlave has 3. And so yeah, if we look at AudioSlave, we can see indeed there's 3. So this is just kind of verifying exactly what we saw. Okay. If you can then further do something where you can run a conditional after some kind of aggregated aggregated command here. Okay, and so here we're running basically the same thing as I have up here. Okay, select artist from album, inner join artist, album inner joins to artist when we match up by using artist ID. Okay, but then and so this gives me an album count, and I might say, you know, I only want artists or results where the album count is greater than 8. Okay, and you don't use a where here. You say having album count greater than 8. So if it's kind of the result after running a group by, so where applies to individual rows in the table, but now we've kind of created an aggregated table with kind of this information. If you want to run a conditional there, you use the command having. So having album count greater than 8. Okay, and so now we get kind of these 5 results: Led Zeppelin, Metallica, Deep Purple, Iron Maiden, and U2, and they have, you know, they all have more than 8 albums and something like that. Okay. I don't know if you guys have additional things. I mean, we can just run some more. We can just kind of explore some of the tables that list appear here. So we've got album and artist and customer and employee and genre and invoice and things like that. I guess I can open the next file as well and just take a peek there. I think, okay, so here we're looking at, we started looking at the invoice tables. But I don't know. Before I go on, are there any questions on any of this stuff? And really, the best way is to just practice writing your own commands. Okay, so I've demoed some of these things, and you know, just ask yourself a question that we might be able to answer using the database, and see if you can write a query to get those things. Okay, and then and again, this SQL exercises thing is really great. Okay. Other things, I guess, that you can do is you can do like silly calculations. So for the command, like this is I think I can do select 10 times 100, and it will just kind of return your result. Okay. Which seems silly, but you know, there might be a time where you need to like be able to calculate some kind of result and put it into the thing. So let me do let me see what I've got here. So if I do artist ID from artist, I think I can do an artist ID times 10 as magic number. Okay, you can do calculations on the columns, something like this. Okay, so this is let's just move ourselves to 10 here. So this is kind of silly, but you can do stuff like that. I guess you can do name. Can I do? I don't know what else I can do. Let's see. SQL count length of string. What is that? Len. Okay. So you can just do that as well, and you can do like length of name as call it name length. Oh, I didn't like it. No such function len. Maybe it doesn't work. Okay. I guess len is not a valid function for SQLite. So some of these things. Okay. So depending on which version of SQL you're running, some of the functions are not available. Okay, so I guess there's SQL Server and MySQL, and they have a few. So in MySQL, it's length. Okay, so not everything is universal. Okay, and I know that seems a little bit crazy, but most of these main things will work. Okay. The join functions, there's a few varieties of joins, okay? And so what we've been doing is we've been using an inner join, but you can also do left and right join. And here's our Venn diagram here. In that, if you're joining one table with another table, inner join will only return values that are common to both. Okay, so if you have that, left join will you specify table 1, left join table 2, and it's going to return everything that's in table 1, but if it's missing on in table 2, it'll still return those. And let's where is this going? Okay. No. I wanted to actually run it. Okay. But I don't know if we have any of those instances in our database, in the Chinook database. Okay. But these are kind of the options that you have. Okay. Inner join, left join, right join. And this is generally an outer join or full join, I guess. Okay. So that's what we have. Okay. I think I'll save this stuff with the other SQL stuff for Friday. We have a few more things. There's a few other expressions in SQL, like there's things called like common table expressions and slightly more advanced SQL things. I think we can just cover the basics and you'll be generally good enough. And really it just comes down to practice, okay? And it's basically, if you understand how dplyr works in terms of like grouping variables together and summarizing and aggregating things there, you'll have a good handle on SQL. The other part is mastering the joins, but I think that's also fairly straightforward and not too difficult. So we'll pause here for today, and then we'll cover the rest of the SQL topics on Friday. Again, some of you guys have come and visited me during office hours for guidance on your projects, and I'm very thankful for everyone who did come. I liked what you guys have said and described, and I always, I don't know, I think my suggestions are helpful regarding things, interesting ideas to pursue and stuff. So don't hesitate to come by, and with that, we'll end here for today, and we'll see you guys on Friday.